Here's question 5, have a go. Okay, so for part A we've got to show that they do not intersect. So basically we're going to need to show that when we combine them and then find the discriminant, b squared minus 4ac, that it is less than 0, and in that case there are no real roots. So first of all, solve the simultaneous equation. So we'll combine them. So basically we know y is this. We're going to substitute this we're going to substitute this into the second equation. So basically we're substituting the curve into the line. So basically rather than 2 lots of y, we say it's 2 lots of 5x minus x squared, because that is equal to y equals 5x plus 4. So we're substituting 1 into 2. Right, and then it's just straightforward algebra. So multiply out the bracket gives us this. Take everything over to the left hand side by minusing 5x and minusing 4. We get this quadratic to be solved. So a is 2, b is minus 5, c is 4. Remember, a being the coefficient of x squared, b being the coefficient of x, and c being the number on the end. So the discriminant is b squared minus 4ac, so substituting this in, we find out that the discriminant is minus 7. This is less than 0, so there are no real roots. Now for part B we've got to sketch this. So let's start off with the straight line. Just find a couple of points on the line. So substitute in with x being 0 and with y being 0. So when x is 0, we get 2y equals 5 lots of 0 plus 4. So 2y is 4, so y is 2. So that's one coordinate, 0, 2. And then when y is 0, so when y is 0, 0 equals 5x plus 4. Rearrange and we get x being minus 4/5. So there are the two where it meets the axes, which we've been asked to do. So just draw in the straight line. Now with regard to the curve, well, go back to the original one before we sort of multiplied it out. This is effectively a pair of brackets really. So our two solutions are with x being 0 and x being 5, because 5 minus 5 is 0. So that our solutions are at 0, 0 and 5, 0. This is a sad face, isn't it? That the coefficient of x squared is a minus number, so that's why it's a sad face. So the curve looks like this. So there's our sketch.